All right, everyone. Hope you all had a good weekend. I'll start off by just reminding everyone that our first exam is going to be on Wednesday. That's in a couple of days. And the way that's going to work is we'll come in here just like this, and then I will be emailing everybody through Canvas a copy of the exam. And then you'll be working on camera, just working the exam out. I'm going to mute everybody's microphone, and then you just work. And then when you're done, you'll submit the exam. I'll give you a link, a Dropbox link like I did last week, and you'll submit the exam. I think I'll have to double check, but I'm pretty sure everybody, there might be one or two people that weren't able to do that, but I think everyone else did. There was one person who sent me like 4 or 5 files instead of 1 file, so that's something that you'll have to work on. But we'll just see how it goes for this first exam. Are there any questions about that?
Oh, I do have a question.
I'm sorry. I know you mentioned that we have a certain time frame to send you our work. What's that time frame? I'll be at work. That's why I'm wondering. So I'm gonna have to take my test here at work.
Yeah, so we meet for normally from 11 to 1:40. So I think we'll probably do half of that time will be the exam, and then the next half we'll just continue lecture. So I would say we're probably gonna go till from 11 to maybe like 12:15, 12:20, somewhere around there. Does that make sense?
And then the time frame, because I know you mentioned that we have to send you all of our work for the test.
Mm-hmm.
When is that due that day? Is it due like right away, or is it due at like 5 or?
No, it's due right away.
Okay.
Is that something you'll be able to achieve at work?
Yeah, I'll probably just have to stay at home and do it.
Well, as long as you can get me pictures, like since you have a special situation, you're at work, if you could just like even text me, because my cell phone number is in the syllabus, right? Okay. So if you can even just text me pictures, that way we know what you had, and then later on when you get home, go ahead and send it to me as 1 file.
Okay.
I would just not like the whole class to do that, because I don't have like, 20 text messages of multiple pictures,
Okay.
Okay, David, you're gonna say something?
Yes, sir. On the Dropbox, I have never used it before. I think I might be the person who sent you like 5 files.
Mm-hmm.
Is there any so it says choose a file, and then I chose the file, but there wasn't any kind of like confirmation that it went through. Should there be? I mean, I just never.
I can double check. When we take our break, I'll double check to see what you sent. But in terms of if you sent multiple files, you're going to have to do something before you actually go to Dropbox. You're going to have to somehow condense those into.
Well, no, I just did it. I just didn't I wasn't sure, because like I said, there was no confirmation that the file was sent, so I just did it like 3 times.
Oh, okay. Well, maybe that's what it is then. Maybe it's the same thing 3 times. Yeah. Okay, I'll double check.
Yeah, that's okay. Thank you.
Okay. Any other questions?
I had a question on the homework.
Yeah, we can go through that. Are there any questions? How about on the exam? You're probably wanting to know like what material it's going to cover, right? So can everybody see the screen? My screen okay? Yes?
Yeah.
Okay. So we stopped, we started talking about polynomials. That's where we stopped last time. We're going to cover this section on polynomials and applications. And then we're going to talk about greatest common factor. And I think that's probably where the test is going to stop. Okay. So portions today, but that's not going to be on the exam. So the material on the exam will stop at greatest common factor. all right, which is,
So after the greatest common factor, there's no way for us to like just review a couple other things that we might not be getting altogether.
yeah, no, we can, you mean today, review?
Yeah.
Before? Oh yeah, we can try and work some time in it at the end. So, this is the first test. So what I think your best approach and the way I'm going to make the test is I'm going to just go look at the homework problems, and I'm just going to pick like a few problems from the homework problems and maybe just tweak the numbers a little bit. And so everything on the test should look familiar, and no surprises is what I'm getting at. So if you want to review, if you're trying to review for the test, just make sure you understand the homework. If you can do the homework problems, you're in good shape. Okay, David, you had a question about a homework problem, and I don't mind. We can talk about some homework problems right now. That's fine with me. What in particular?
Yeah, it was. I'm sorry, this printer's going.
That's fine.
It was page 10, part C, number 28 or 29.
Okay. Page 10. Okay. 28 or 29. One of these solved ones? Wait, no, hold on. That's not the homework.
Yeah, one of these. That was right. That was right. You're good.
Right. Okay, so one of those.
Either 28 or 20 with the x over 3 thing. I just wasn't sure what to do with that, or the x over 4.
Yeah. Okay, so let's just do them both. All right. Number 28. So look at the instructions here. It says here to simplify or solve. Okay, so that means you have to look at it and understand what you're looking at. So on the first one, this right here is an expression. All right. Can you all see that okay? Because I got a new thing that I'm writing on, and I'm not quite sure how it's going to show up on your end. Is that clear? Other than my bad handwriting, is that clear?
Yeah, it's pretty good.
Okay. So that's an expression, and number 29 is an equation. So there's a difference between those two. And so
Your audio is going in and out.
Okay, so my audio's no good?
It was going in and out right now. I don't know if I was the only one.
Okay. Let me know if it continues. I have another microphone set that I can use. Okay, so with the equation, I've got the equal sign, right? And with the expression, there's no equal sign. So if we're going to do number 28 and they want us to simplify, that means all they want us to do is combine things together to make it look better. So let me go and try and do that now. So when we look at this, the only thing that I see that I can combine are these two right here. And that's because those are like terms. They both have X in them. So it's kind of like if I told you, if I wrote like 4x plus 2x, of course you could combine those together to get 6x. Well, we're going to do the same thing with those. So one thing to, I guess, note is that when you see x over 3, you need to realize that that's really like 1/3 x. And then the 1/4 x, they actually have it written the way that I want you to kind of visualize it there. So everyone see that that's the same expression?
Yeah.
No? Jessica? No? Okay, so
No, I'm
when
confused. You lost me.
when you have x over 3, right? So I'm looking at this piece right here. I'm telling you that that's the same as 1/3 times x over 1. Do you agree with that? If I asked you to multiply those two fractions together, you just multiply straight across, and you get x on top and 3 on the bottom.
Okay. So,
Yeah, and then instead of writing x over 1, I'm just going to write 1/3 x.
okay.
Yes? Okay. So when I gave you this problem, 4x plus 2x, said we could put those together, and that would give us 6x. And all we're doing there is just adding 4 and 2 together, right? To get the 6x.
Yeah.
So we want to do the same exact thing here. We want to take the 1/3 and the 1/4, and we want to add those two together. And then whatever that is, we'll put it in front of x and we'll be done. At least with that part. So let me clear this out here. This is just going to be some kind of scratch work I'm going to do. I want to know what 1/3 plus 1/4 is. So I'm doing this kind of on the side here. And to do that, we can do that little thing I showed y'all where you go 1 times 4 and 1 times 3 and then 3 times 4. And
7
what would that turn into? I'm sorry?
7/12.
7/12. 7/12. Okay, so I've got a lot of stuff written down here. Let me just kind of get all this out of here. Okay, so what we're saying is that these two put together, right, give us 7/12 x, and then we still have -1. Now we can't do anything else. I mean, that's it. You can't combine anything together. You can't put the x and the 1 together because they're not like terms. So at this point, we're done.
Oh, that's where I keep messing up at. I think I got to keep going.
Yeah, that's it. So with an expression, you're just trying to clean it up, make it look better. But at some point, you have to stop because there's nothing else you can do.
Oh, okay.
Now, this next problem, 29, we have a major difference in the way we're going to attack number 29 because it's an equation. And because it's an equation, we can use a slightly different approach. When we have an equation, well, we actually have a linear equation, right? We talk about linear equations. You're looking for an equation. You're looking for a variable. The variable has to be raised to the first power. So we have a linear equation here. And the steps for the linear equation, the first step is, of course, C, make sure it's a linear equation. Second step is to simplify, right? To try and simplify both the left and right-hand sides. So do you agree that at this point, we could clear fractions? So that was a technique we learned last time. We could clear the fractions. Yes?
Yes.
Okay. So to clear the fractions, we have to look at the two denominators, 3 and 4, and we have to come up with the least common multiple. So what would be the least common denominator, least common multiple of those two numbers? 12, right? 12. So what we do now, very important next step, is we're going to take the left side of the equation, we're going to multiply it by 12. And then take the right side of the equation and multiply it by 12. So we can do the right side first. 12 times 1, that's just 12. So there's not a lot of work to do on the right side. But on the left side, we have to distribute the 12 through the parentheses. So the 12 has to multiply by both of those. And I'll go ahead and do that on the side. On the first multiplication, 12 times x over 3. Y'all see what I'm doing there? I'm going to multiply the 12 times the x over 3. When I do that, you might want to look at that as being 12 over 1 times x over 3, and then just multiply straight across. You can also reduce. If you want to reduce, you can reduce, or you can just go straight across. What do y'all want to do? Reduce first or across?
Reduce first, I guess.
Reduce.
Okay, we can reduce. So 3 goes into 3 once, and 3 goes into 12 4 times. So we should just get 4x on top and 1 on the bottom, which is just 4x. So that's what we get on the first distribution. And then the second distribution, which would be the 12 times the 1/4 x, when we do that, same thing, I can look at that as 12 over 1 times. Now here, this is, I think people get confused with this. Just leave your x out to the side. I'm going to put a dot there because that's really, that means 1/4 times x. And let's simplify. Again, let's reduce. 4 goes into 4 once and 4 goes into 12 3 times. and then go straight across. What would we get if we went straight across there?
3x.
3x. Okay, so the left side of the equation becomes 4x plus 3x, which is something we can combine together. And the whole idea here is that we have no more fractions, right?
Yeah.
So we should be able to put these together because they're like terms. That should give us 7x equals 12. So we simplified, collected like terms. Now we want to get all our x's on one side of the equation, which we already have. All the x's are already on the left side, everything else on the right side. So the last step would be to try and get a coefficient of a 1. Oh, that's no good. There we go. Okay, so we want to get that 7 to be a 1. How do we do that?
Do we might divide it?
Divide by 7 on both sides. So 7 here, divide by 7 here. 7's canceled, become a 1. And we get x on the left side. On the right side, our answer is 12 over 7. There we go. Hold on a second. I've got this Alexa device that's talking to me. Okay, does that clarify the differences between those two problems? Real good. So there's a big difference between having a minus sign there versus an equal sign on those two problems. Okay, any other questions on homework?
I have one more real quick.
Okay.
If you had something like 1/2 x plus 2x equals 1, would you just combine the 1/2 x and the 2x, or would you get rid of that fraction by multiplying?
1/2
I
x
guess you could.
plus 2x equals 1.
Yeah, something like that. Would you just combine the 1/2 and the 2? I mean, this is like a super simplified version, but would you combine those two, or would you get rid of that fraction first?
That's up to you. You could do it both ways, actually. But if I'm going to stick to what I've been, go ahead.
Oh no! You're probably about to tell me right now. I'm going to ask. I was going to say, to get rid of that, how would you get rid of that fraction exactly?
I would multiply both sides by 2.
Okay,
Because
that's what I thought.
the only denominator I have is 2. So I would multiply the left side by 2 and the right side by 2. And when I distribute through, I'd wind up getting x plus 4x equals 2. And then I put those together, you get 5x equals 2. And then I divide by 5 and I get 2/5.
Okay.
So that's me going very fast. Now, if you wanted to combine those together, you could. That's perfectly fine. Now, I didn't do that on this problem before. I did not. I could have actually combined these two together. I could have done that, but I didn't, because the technique that I've told you when you have an equation is to try and clear the fractions. And that's just so you don't have to deal with fractions.
Yeah. But either way it would be correct.
That's right.
As far as like doing work and everything.
Yep.
Okay, great.
Any others?
Yeah, I have one. Where is it? Number 7 on page 11.
Page 11, number 7. Okay, gotcha. All right, so we're looking at this one right here. What did you do first?
I didn't know what to do first.
Okay, so let's talk about the operations that we have here. Between this 7 and this 2, that's a multiplication. We have an addition here. We have another multiplication here. So we have multiplication there, we have addition, we have multiplication, then we have subtraction, right? So we're supposed to do what's in parentheses first. And the only thing that I have in parentheses is a 1/2. And there's nothing you can do with 1/2 to simplify it. Like 1/2 is 1/2, right?
Okay. Yeah.
Okay. I don't have any exponents. Now, I also told you that if you see a square root symbol, to treat it like a parenthesis. So we really do want to look inside that square root and look at the 25 and see if there's anything we can do with it. But again, 25 by itself is just 25. Like there's nothing I can do with 25. I can take the square root of it, but 25 by itself is just the number 25.
Okay.
What I'm trying to say is if that had been something like 25
Minus
plus 4, I would do the 25 plus 4 first.
All right.
Okay, so at this point, we really don't have anything that we can do in terms of parentheses or exponents. So that means I want to do multiplication division from left to right.
Oh, okay.
Question.
I'm sorry?
So since I have a question. So since there's nothing with the square root, you don't want to just take it and just make it 5?
You can. You can.
That
You
you
can
would do something with it if it was like 25 minus 5 or whatever.
yeah. You could do the square root 25 right now. Okay. I'm just going to follow the order of operations. And really in our order of operations, there isn't really,
A square root, right?
well, technically speaking, the square root of 25 is an exponent.
Oh, okay.
Because the square root of 25 actually means 25 raised to the 1/2 power. Okay, but we haven't necessarily talked about that. So we should technically do the square root of 25 first, but since we haven't done this yet and talked about, that's called rational exponents, we haven't talked about it, I'm not going to assume that you would have known that. So I'm going to go multiplication and division from left to right. And I'm going to start with this. So I do -7 times 2, that should give me -14, plus 8 times 1/2 minus the square root of 25. Trying to get used to this new style as my writing is really bad. I'm going to do the next multiplication now, that one right there. So I'm going to have -14 plus, what's 8 times 1/2? Or what's 1/2 of 8, right? That's what that's really saying.
That's where I got lost there, right there.
Okay, so you're just doing 8/1 times 1/2. And you're going straight across or reducing first. So if you just go straight across now, you get 8 divided by 2, which is 4.
Yeah. So it's going to be 4/1.
4.
So yeah.
Yeah. And then minus square root of 25. And I think at this point, I think it's time for us to take the square root of 25. -14 plus 4 minus the square root of 25 is 5. And then I'm just going to continue now left to right. So what happens if you have -14 and you add 4? What do you get?
-10.
-10. And then you have still -5 there. And so you have -10 minus 5, that should give you -15. Is that clear?
Yep. Now it is.
Okay. Okay, I'll open the floor again later for more questions. Let's get to today's material. We were talking about polynomials last time, and I talked about monomials, you know, what is a monomial, and then a polynomial is just monomials put together, and that's kind of where we stopped. The main idea here is that if you have a number with some letters, like let's say we have x squared, we can add that to another 3x squared. We can add these together so long as we have the same variables raised to the same power. So it's like apples and oranges. Those two, you know, those two things here are both apples, so we can add them together. We have 4 of them and then 3 of them, so when we add them together, we should get 7 of these things. If I change it to 4xy plus 3xy, again, they both have xy. So if you have 4 of something added to 3 of them, you should have 7 xy's.
Is this number 4?
I'm sorry?
Is this number 4 or is this your own
No,
example?
this is just me thinking about the idea of this, okay? Like, how can you combine monomials together? They have to have, the key is for you to be looking at the letters and the powers on the letters. As long as they match, we can add them together. Like this one, could I add this? Could I add those together?
No.
No, I cannot. And the reason why is because on the first one, we have x squared, but on the second one, we don't, right? We just have x. And then we have y, but on the second one, we have y squared. So they don't match up, so we can't add them together. Those are not what we consider like terms. So let's get started with this section. Start with the first one. And the instructions here are to perform the indicated operations, right? Perform the indicated operations. So when we look at this first one, we have this 3a plus 2a squared plus 3a squared, or 3a cubed. And we are subtracting from that a plus 2a squared minus 3a cubed. So the operation here is subtraction. So I guess the tricky part of this problem is that you've got to get rid of the parentheses. To subtract two things, you can't have the parentheses there. So on the first expression, I can just leave it alone. I don't have to change anything on it because in front, and this is the part that's confusing, in front of this parentheses, there's a 1. Even though you don't see it, there's a 1 there. So you can almost imagine that we distributed a 1 through the parentheses, and 1 times anything is itself. So nothing changes on the first one. But on the second, go ahead.
So that imaginary 1, that's like always, or just within polynomials and stuff?
No, it's always there.
Oh, okay.
There's a 1 right there in this number 2, right? There's a 1 there. You know, there's a 1 here.
Oh, okay.
I could just tell you drop the parentheses, but I want you to understand the reason why is because you're actually distributing a 1 through. But look at the second parentheses. What would be the number out in front of the second parentheses?
-1.
It'd be -1 because there's a minus there. So you need to see that there's a -1 right there. And now when you distribute that, what is multiplying something by a negative number going to do?
And to a negative.
Yeah, it'll change anything that's positive to negative, and it'll change anything that's negative to positive. So I'm going to wind up getting -a minus 2a squared and plus 3a cubed. That's all because that subtraction symbol really is a -1 being passed through. And at this point, we try and combine now things together. So when I look at this, the first thing I see here is a 3a. I'm going to look to see if I have anything else that has just an a in it. Just a, not a squared or a cubed. And I see I've got this minus a. So what would be 3a take away an a?
2a.
2a's. So we have 2a's. Okay, let's see. Let's talk about the a squareds. I've got a 2a squared, and I've got a minus 2a squared. So what would that be?
Just cancels.
They just cancel out, so there's nothing. I can just get rid of them. Oh. And then I look at the cubes. 3a cubed plus 3a cubed. I can put those together. How many a cubes would I have there?
6a cubed.
6. So plus 6a cubed. And that's it. You can't put those two together, right? They're not like terms.
Okay, real quick, I know that you said it was -1 and you did that for the second parentheses. And then how'd you get, why is it a -2 and then it's +3?
So on the first parenthesis here, that a is positive, right? It's just a, right? So when I multiply it times a negative, a positive times a negative is negative. And that's why I put a negative here. The second term is positive 2a squared, but I'm multiplying it by a negative. Positive times a negative is negative. And that's why I put the minus there. This third term is a negative, right? It's minus, but I'm multiplying it by a negative, and negative times negative is positive, so that's why I put plus here. It just changes all the signs. That's all it does. A negative being passed through parentheses or distributed through parentheses just changes the signs of everything that's there.
Okay.
Okay?
Yeah.
Now look at number 2. Number 2, can I get rid of these first sets of parentheses? Can I just drop them? Can I just get rid of them? What's the number out in front of that parenthesis?
So 1.
It's a 1, right? So if it's a 1, I can just get rid of it, right?
Yep.
Okay, so I can write 3a plus 2a squared plus 3/5 a cubed. Now, in front of the second parenthesis, right? These are my second parentheses. What's the number out in front of that?
It's going to be 1, right?
1 again, right? So if it's a 1, I don't have to worry about changing signs like we did in the previous problem. I can just drop the parentheses again. So it'll just be plus 6a minus 2/5 a squared and then minus 3a cubed. I don't know if I like this. 3a cubed. Okay, so now I can start combining things together. So I'm going to look for my a's first. I have a 3a and I have a 6a. And if I put those together, I should get 9a. I have a 2a squared and then, oh shit, I've got a 2/5 a squared, right? So that's no good. I mean, it's good, but it's not good because what are you going to have to do to figure out what that is?
You're going to have to 2 over 1.
2 over 1, and you're going to subtract from that 2 over 5. So be careful because we're not multiplying, right? We're subtracting. It's kind of like if I said, what's 4x take away 2x? You just go 4 minus 2.
Yeah.
Here we're saying 2a squared, we're taking away 2/5 a squared, so we have to do 2 minus 2/5. And how do we do that subtraction? Well, we've done this, right? Do that.
Multiply down. Yeah, multiply across.
Okay, so you should get 10 take away 2 over 5. Which is 8 over 5, right?
Yeah.
So you get plus 8 over 5 a squared. And then we still have one more to do. We have the plus 3/5 a cubed and the minus 3a cubed. So again, I have to do another scratch work on the side here, but this time I have to do 3/5 and take away 3, which I'm going to write as 3 over 1. Then I have to do that little cross thing again. So I go 3 times 1 first, minus, and then I do 3 times 5, which is 15, and then over 5 times 1, which is 5. And what is 3 take away 15?
3 take away 15, negative 12.
Negative 12, so we're going to have minus 12 over 5, and then a cubed. Don't forget the a cubed. There we go. So, I mean, in a problem like this one, you can kind of see how I could just ask you a problem like this on the test, and you would have to be able to add and subtract fractions, wouldn't you?
Yeah.
So I may not ask you a problem from the first sections where I ask you to add fractions and subtract, because this problem it's built in. It's kind of like kill 2 birds with 1 stone, kind of. So it's more likely for you to do something like this than it is for you to just see me give you a problem like I probably will not give you a problem like that I just put in green, because I could build it into another problem. Okay, let's look at number 3 and just talk about it. I'm not going to do it. I'm just going to talk about it. On the first set of parentheses, can I just drop the parentheses or not?
Yes.
Yes, because there's a 1 out front. Okay. How about the second set of parentheses? Can I just drop those or no?
No.
No, because there's really a -1, right?
Yep.
So that's got to distribute through, and that's got to change the sign. So I'm just going to write down what this would become. Minus a plus 2/7 a squared, and then plus 3a cubed. That's just what that second part would become. Out front, you'd still have this, 2/7 a plus 2a squared plus 3/5 a cubed, and then you'd have to put everything together. And there's definitely some fractions and stuff you'd have to mess with there. I'll just highlight what goes together. You got to put those together. You got to put those together. And you got to put those together. Okay, so that's like 3 separate little problems you got to do on the side. You good with that? I'm just going to say ... meaning you could figure out the rest, hopefully. Okay, moving on. Number 4, very different problem. Because now what we're doing is we're going to do multiplication. So you have to go back and you have to think about, you know, like if I wrote down, you know, 5 squared, what did 5 squared mean? It means 5 times 5, right? So if you ever square something, it means you're going to multiply it times itself. So if we write 4x minus 3, that whole thing in parentheses, if we write that squared, then that really means I have to do 4x minus 3 and multiply it times itself, 4x minus 3. And when you do this multiplication, you have to use a technique. Does anyone remember the name of the technique that they teach in a lot of schools?
FOIL.
FOIL, have y'all heard of that before? FOIL. FOIL is this acronym that helps us remember how to multiply these things together. The F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So that means to multiply these two together, I have to do the first ones together first, all right? And what I mean by first is this 4x times the 4x. I have to multiply those together. So what's 4x times 4x?
16x.
16, close, close. 4x times 4x is 16, because we're multiplying, but then x squared because it's x times x.
Oh, okay, so 16x squared?
16x squared is the first result we get.
All right.
Okay, then we do the outer ones. The outer ones means you're looking at the outsides of the parentheses. So that means the 4x times, be careful, times the -3. So what would 4x times -3 be?
-12x.
4x times -3 would be -12x. So minus 12x. All right, now I need to do the inner ones. The inner ones are the inside two, which is going to be -3 times 4x. That's kind of like what we just did, -3 times 4x.
Would be -12x.
That's another -12x. And then the last one we do, let's see.
-3 times -3.
Yeah, so the last ones we do, -3 times -3. What is -3 times -3?
+9.
+9, so +9. Now we're almost done. We're almost done, but there's one more thing we can do here. What is it?
Combine the like terms or no?
And like terms, those two both have x's. So we can do 16x squared minus 24x plus 9. There we go. That is it.
That's the answer?
That's the answer. Because we can't do anything more with that. We can't combine anything together. So this whole FOIL thing, I'm trying to think of how I want to say this. I'm going to write something down right here. That 16x squared minus 9 is the most common incorrect answer that I get on this. Do y'all see what that student did? A student that would give me that answer. Do you see what they did?
They try to cancel them out.
Oh yeah, they canceled the X's out, right? The 12 X's.
I'm saying the student that gets this problem, okay, I'm going to erase this because it's just getting in my way. And then they give me this answer right here. I'm saying, do you see how they got to that answer?
Oh yeah, they're just squaring the 4x squared
Yeah.
and then just square the 3.
They squared the 4x, which gave them 16x squared.
Oh
and,
yeah.
and then they squared the 3, and that gave them 9. That's the most common incorrect answer that I get. They did not do the FOIL. Okay. So I want to just take a moment because I really want you to maybe understand why this doesn't work that way. So I'm going to give you this completely different example, but hopefully it'll help you understand why we do FOIL. Let's say I tell you that I want you to do x plus 3, and I'm going to bring up a grid here. Yeah, it's too big. Okay, what if I tell you I want to do x plus 3 and I want you to square it? Okay, so that's what we'd like to do. I'm going to draw something, try and make this visual. Oh, and I should also, before we do this, I should make sure everyone agrees on something. If I draw a rectangle, boy, that's not a very good rectangle. But if I give you a rectangle, I tell you that the length of the rectangle is L and the width of the rectangle is W. Do y'all know the formula to get the area of a rectangle?
Length times width.
Length times width. Okay, most people are comfortable with that. Okay, you need to agree with that before I continue here. Okay, so I want to try and convince you why we have to FOIL on this and why the answer is not x squared plus 9, why it is not just squaring each one. So let's do this. I want you to imagine that I have a tape measure in my hands and I want to measure out a certain distance, and I'm going to put it down here and I'm going to measure from here to, let's say, here, and I'm going to call that distance. I'm not telling you what it is. I'm going to call it x. Okay. And then I'm going to get my tape measure and I'm going to add 3 more to that. So from that endpoint, I'm going to add 3 more. So from here to here is 3. Can somebody tell me what the total distance is from here to here?
X plus 3.
It's just x plus 3, right? Does everyone agree that that's x plus 3? Yeah?
Yeah.
Okay. I'm going to do the same thing, but I'm going to draw it vertically. So I'm going to go out a distance of x. Okay. So this is x. And then I'm going to measure out 3 more units. 1, 2, 3. That's 3. So what is the distance from here to here?
X plus 3 again.
X plus 3 again. Okay. Now, remember that x plus 3 squared really means x plus 3 times itself, right? That's what it means. Okay. I'm going to continue drawing on this thing now. I'm going to draw a couple of boxes here. Okay. So remember what you told me a second ago about rectangles in the formula. Do you all agree that this big box right here, the big blue box, do you all agree that that is x plus 3 times x plus 3? Yeah?
Yes.
Because we already said this is x plus 3, and this side is x plus 3. So the whole box, the area of that should be this thing that we're looking for, right?
Yeah.
Okay, but let's look at the smaller pieces. What is the area of this little green box right here? So how long is each side on that box?
X.
X, and then X, right? So shouldn't this be X times X, which is X squared?
Yep.
No, okay. What about the yellow box here?
That's 3.
3 is this side, yes, but how tall is it? Isn't it X?
Oh yeah, it's X.
It's X, right? So shouldn't this be 3X here? How about this box? How wide is that box? What's the width from here to here?
X.
X, okay. And then what's the height of it from here to here?
That's 3X.
3, so that's 3X. Okay. And we have one more box to worry about, which is this one. So how wide is it?
That's 3.
And how tall is it?
3.
And so the area of that should be 9, shouldn't it?
Yep.
So if we add all these up together, it should be the total area of this thing. So shouldn't our answer be X squared plus 3X plus 3X plus 9? And that should be X squared plus 6X plus 9. That's what the answer should be. It should not be this. This is wrong. That's just visually showing you why it doesn't work to just square each one. Because when you look at it visually, you can see that there's more there than just those two pieces. X squared plus 9 would just be the corner boxes. You'd be missing those others. I hope that visually kind of gives you some glimpse
Yeah,
into
it
why
does.
we use formula, the FOIL formula. Okay.
So when do you know the only time you use that FOIL is when it has like the parentheses? Like when do you use it?
Okay, good question. FOIL is only used, I don't want that, hold on. FOIL is only used, and this is, I personally do not like FOIL, all right? And here's why. Because FOIL is only used when you have what we call a binomial times a binomial. So I have to have something like this, x plus 3 times, let's say, x minus 4. So in other words, you have, in here you've got 2 terms. In here you've got 2 terms. And whenever you have 2 terms and you're multiplying 2 terms times 2 terms, you can use FOIL. But if you had 3 terms and 2 terms, you can't use FOIL anymore.
Oh, okay. So if there was 3 terms in this parentheses, you couldn't do it?
Couldn't do it.
Oh,
You couldn't use FOIL.
yeah.
There's a way to do it, but I do not believe it's within the scope of this class. No, it is number 5. Yeah, we have to do it on number 5. Do you see number 5?
Oh, yeah.
So the question is, how do we do this then, right? So number 5, we cannot use FOIL because we've got 2 terms in the first one, and we've got 3 terms in the second one. So here's the method, all right? I think it's a pretty clean method. It's a pretty simple thing to follow. Let me run through it one time and see if it makes sense. What we're going to do is we're going to look at the first term, x, and we are going to distribute the x through the parentheses and multiply it times everything we see there. And so we have 3 multiplications we have to do there. Once we're done with that, we are then going to take the second term and we are going to distribute it through the parentheses, and that will give us an additional 3 terms. So we're going to wind up having six terms at the end. All right, so I'll even label these. This will be our first multiplication, our second one, our third one, our fourth one, our fifth one, and our sixth one. So let's do it. What's the first multiplication? X times x squared. What would that give me? I thought I heard someone. Huh? No. X times x squared should give us x cubed.
Oh, yeah.
Okay, how about multiplication number 2? X times 3x.
4x?
Ah, good. Okay, so we're doing x times 3x, not x plus 3x. X plus 3x would give us 4x. Here, we're multiplying, right? So
Mhm.
all you're going to do is put the x's together. And what's x times x?
Oh, x squared.
X squared, right? So we write that as 3x squared. That clear? Okay.
Yeah.
And then the third multiplication, we're doing x times 9.
Is 9x.
9x. Okay, 3 down, 3 to go. So now the fourth multiplication, we're doing -3 times x squared, which will give us minus 3x squared. The fifth multiplication, we're doing -3 times positive 3x. What would that give us?
Negative.
-9. 9 what? -9.
Negative 9x.
X, right? We still have the x there. And then what's your last multiplication?
Negative 3 times.
Excuse me. -27. We're not done. Collect like terms.
Okay, so
X
3x.
cubed. Yeah, we can put the 3x squared and the minus 3x squared. Those are going to cancel, aren't they?
Yep.
Don't the 9x's cancel too?
Yeah.
Okay. That's just the way it is. For this problem, that's what happens. All we have is -27. That's it. X cubed minus 27. There we go.
So x cubed minus 27.
Yep, and that's it. So number 6, I'm not going to work through, but I'm going to talk about how you would do it. So when you look at this one, you need to recognize that you have multiplication between those two. And so these first two, you've got to FOIL those, all right? And you FOIL it because it's 2 terms times 2 terms. So you'd have to do that FOIL. And then what am I going to have to do on the second one over here with this parentheses? I need to get
-1.
Yep, that -1 has to distribute through. And then you'll put everything together at the end. So you do your FOIL, it's going to come up, you're going to come up with some stuff here. Then you're going to have like -3r minus 2r squared plus 7. That'll come from here when the signs change. And then you'll collect your like terms. So I'll leave that one to you to do. Okay, let's look at applications. So answer the following. Write the polynomial that represents the perimeter of the triangle. So we need to know what a perimeter is. Do y'all know what the perimeter of a triangle is, or a perimeter of anything?
No, the area.
No, the area is the stuff inside of it. The perimeter is, think about like the perimeter of your house, right? Or your, wherever you live. It's a measurement of how long the outside of something is. So what we're being asked to find is the distance. If we were to walk around this triangle, right? If we were to start walking around this thing, they're asking us to figure out what the distance is. But they've given us the 3 sides, haven't they? They've told us what the 3 sides lengths are. Now they don't tell us because we don't know what x is. But doesn't this mean we just need to add those up? We just need to take that. That's how long the first side is. We need to add that to the second side. And then we need to add that to the third side. And so we're just going to add them all up. Can we drop the parentheses on all of them? Do we have any minuses to worry about?
No.
So we can just drop the parentheses and then collect all like terms together. So if we do that, just imagine the parentheses weren't here, so I'm just gonna get rid of them. How many x squareds would I have?
2.
Shouldn't that be 5 of them, right? So remember, we're adding them, right? Not multiplying. So we should just have 5x squareds. how many x's? So we have -4 plus 5 plus 4. There's 3 of them to worry about. That should give you how many?
-4 plus 5 is -9.
5x.
You just have 5x. And then you still have a number. 9, add 3, take away 10. So that should leave you, I think, with 2 plus 2. So that's it. What they wanted was a polynomial that gives you the perimeter. And this is the polynomial that gives you the perimeter. So now if someone were to give me what x is, I could tell you the distance around that. Someone would have to tell me what x is, though, for me to be able to give an answer. But this is the answer the way they want it. On number 8, it says to find the polynomial that represents the area of the shaded region. So the area is a measurement of the stuff inside. So they want us to figure out a polynomial that would tell you how much stuff there is inside this thing. Anyone have an idea of how I could figure that out?
Well,
I want to say multiply the size.
So multiply this side times this side.
Yeah, but
Length
Then you're
times
gonna have
width times height.
yeah.
So I'm going to multiply those two sides together. So I'm going to write it as squared, right? Is that okay? I'm going to multiply those two sides together. Everyone clear on that? That would give me the area of the whole thing, wouldn't it? But that would actually include this stuff in the middle. I actually don't want to include that. So how would I handle that?
Find that area and subtract it from
Yeah,
the 2x.
exactly. Why don't we take out, so why don't we take out of this answer the area of the inside here? Which, what is the area of the inside? Because they tell you the two sides are x, right? So the area of that
X squared?
inside should be x squared. Is that clear to everyone? You're almost looking at it like this. You have a big box, and you're going to subtract the area of a small box. The big box is the outer one here. And that's the area of this is 2x minus 5 times itself. And then the inside box, which is this one, is that one right there. And you want to take that one away, so that's why I subtracted, and the area of that one is x squared. So that's where this comes from. Now, we're not done, because what do we need to do with that thing in parentheses?
Distribute or
Yeah,
Times by itself.
Yeah, you have to actually
Simplify or whatever.
do the FOIL. You have to do the FOIL on that one, and then you'll minus the x squared. So I think I'll leave that to you. You have to FOIL. And get your answer. The more important thing is for you to understand how we came up with that from the picture. Okay, that is it. These are the, oh wait, these are some more. Okay, I think I can talk through these. Number 9, they want us to find a polynomial that represents the perimeter of this parallelogram. So all you're going to do there is take these 4 sides and add them up. 2x plus 1 plus 3x plus 4 plus 2x plus 1 plus 3x plus 4. So you're just going to do addition, then collect all your like terms together. That make sense?
Wait, say that again?
You're just going to take all those and add them up, because you're trying to find the perimeter, which is distance around.
Oh, okay.
You're going to do like 2x plus 1 plus 3x plus 4 plus 2x plus 1 plus 3x plus 4. And then you can drop the parentheses because there's no subtractions, and then you collect like terms. Okay, let's look at this last one here. Write the polynomial that represents the total number of square feet for this floor plan. So what they mean by that is they want to know the area of this thing. So let's do this like, this is a floor plan, like an apartment floor plan or something. Let's do this one at a time. What is the area of this room right here? So that's a rectangle. So the area is just length times width. So what would that area be?
X times X plus 6 feet.
X times X plus 6. Okay, what's the area of this red room right here? So how tall is that room, or what's the width of the room?
12 feet.
12, and you're multiplying that times the X plus 6 again, right? Because that's how wide the room is.
Oh, yeah.
And then what about the last one here? This blue room.
It's 12 feet.
12 feet times
24.
24. So you can find the area of each room, and then you need to add them up. So what we need to do is 12.
The area of that blue room's wrong. It's 24 times X plus 12.
Oh, yeah, good. Thank you for catching that.
Hey.
Who's that? Dalton? Who's that? Good job, Dalton. Yeah, I should have put a thing to represent this whole side. Yeah, it's the 12 and the X.
Oh, okay, yeah.
Right, it's the whole distance. So we have the 24, which is how wide it is, right? And then we have the X plus 12. So we have to take all three of those things and add them up. So we have to take the 12 times the X plus 6. We need to add to that the X times the X plus 6. And we need to add to that the 24 times the X plus 12. And so you'll have to do some distribution first, distribute 12 through, distribute X through, distribute 24 through. And once you do the distribution, then you come through and collect like terms. I'll just go ahead and finish it out. It's 12x plus 72 plus x squared plus 6x plus 24x plus, let's see, what's that, 240, 288, I think. Someone can check my math on that. 24 times 12. Is that right?
Yes.
Okay. So just distributing there and now collecting like terms. So when you put these together, we like to put them in what we call descending order. That means the highest power of x down. So maybe I should mirror my camera so that it looks like I'm going left to right. It looks like I'm going right to left, doesn't it? When I do that?
So 24x plus 12x plus.
Yeah, I'm gonna do, let's do these. So I'm gonna put x squared first. Get that out of there. And then I'm gonna do, why is that like that? Where's my mouse? I've lost my mouse. Okay. So x squared, and then I'm gonna put the 12x together with the 6x together with the 24x. So I think I'm gonna get 42 x's. And then lastly, the 72 and the 88, gotta put those together. So what's that? 360?
That's 290 plus 70. Yeah.
360?
Yep.
There we go. Okay. All right, so those are the problems, polynomial stuff we're kind of done with for now. Operations, just be careful of distribution, getting rid of those parentheses, collecting like terms, foiling. All right, we're gonna move on. It's a good time, I think, to take a little break. We'll take a 10-minute break. It's 12:05. We'll come back at 12:15. We'll finish off greatest common factor. I don't know how much more we're going to get into after greatest common factor. Probably be able to get into some of it, some of this percent stuff. So, okay, 10-minute break. All right, everyone, 12:15. We'll get going again. So as we get started here, I just want to remind everyone that on Wednesday, you're going to have to be able to broadcast your video. So if your computer does not have a camera, you're going to have to log on using your phone or using a Zoom app on the phone or something like that, so that, to be fair to every student, you know, I can't have 10 of you on camera and the other 10 not. Everyone has to be. So if you can't get a camera running, you can't take the test. So make sure you get that squared away before next class. Okay, we're going to be talking about greatest common factor right now. And to kind of get us going on this, I want to first talk about factor. Ooh. I want to talk about what's called prime factorization. I think I'll get better at my handwriting on this thing. It's not too great right now. So prime factorization. First, we need to know, what are the prime numbers? So by definition, a prime number is a number other than 1 that is only divisible by itself in 1. So the list of prime numbers are 2, 3, 4 is not a prime number because 4 is divisible by 2. So 4 is not a prime number. 5 is prime. 6 is not a prime number because it's divisible by 2. 7 is a prime number. 8's not. In fact, no even numbers after 2 are prime, because any even number is divisible by 2. So every number that's prime from here on out should be odd. Is 9 a prime number?
No.
Number 9. No, because it's divisible by 3. So it's not prime. How about 11?
Yeah.
11 is. 13 is. 15? No, because it's divisible by 5 and 3. So you could keep going. And this list goes forever. There actually isn't, there are an infinite number of prime numbers out there. So when we talk about prime factorization, here's what we mean. If I take a number like the number, let's say 28. Okay, take the number 28. 28 is not a prime number, but we can write it in what's called its prime factorization. And the way we do it is using what's called a factor tree. So can somebody give me 2 numbers that multiply to be 28? Any 2 numbers you can think of.
7 and a 4.
7 times 4. So 7 times 4, everyone agree? Now, is 7 prime?
Yes.
Yes. Is 4 prime?
No.
But you could rewrite 4 broken down to be 2 times 2, right? And then if I bring the 7 down, put it here, now 7 times 2 times 2, right? 7 times 2 times 2 would give you 28. But notice that every number there is prime. That's called the prime factorization of the number. Another way we could write that is 7 times 2 squared. Do y'all agree? Because 2 times 2 is 2 squared.
Mm-hmm.
Okay, so that is called the prime factorization. Any number that is not prime, okay, any number that is not prime is what we call a composite number. And that means that it's made up of primes. And every composite number can be broken down into its prime factorization. Every number. Okay? So what we're about to do is we're going to start this thing called factoring. And factoring, by definition, I'm gonna go to a different page here for this. Factoring is basically turning addition and subtraction into multiplication. That's what it means to factor something. So I'm going to give you an example. If I asked you to do 6x times x plus 3, I'm asking you to multiply this 6x and distribute it through. We've done that before, haven't we? We've already done that.
Mm-hmm.
If we did this operation, we would get 6x squared plus 18x. I hope you all agree with that. That is not what factoring is. Factoring is starting here and ending here. So it's the reverse operation of distribution. It's getting something that has only addition in it, right? That has addition, and turning it into something that had multiplication between two things. So that's what factoring is about, turning things that are added into things that are multiplied. Now, when it comes to factoring, factoring is very complicated. There's a lot of different techniques to factor. But the very first technique, the very first step to factor anything, okay, the very first step is to do what's called the GCF, or the greatest common factor. That's always the first step. And so that's all we're going to talk about right now is this greatest common factoring. Trust me, there's more steps, and we'll talk about those later, but we're just going to talk about GCF today. So let's get back and look at this first problem here. And we have 6y squared plus 6. I'm looking at number 11. 6y squared plus 6. And it says to factor out the greatest common factor. So the way you do this is you look at each of the two terms, 6y squared and 6. You look at both of them, and you start with numbers. So you're trying to figure out, is there a number that goes into both of those numbers? So can someone think of a number that goes into 6 and 6? 6, right? Now, would two go into both?
Yes.
Yes, but we're trying to find the greatest thing they have in common. And the greatest number that goes into 6, both sixes, is 6 itself. Okay, so what I'm going to do is I'm going to write down 6. Okay, then you look at the letters, and you have a y squared here. Do we have any y's in the second one?
No.
No. So to be a common factor, it has to be common, which means it has to appear in both. And since y squared does not appear in both, they don't have any y's in common. Therefore, 6 is my only common factor. So what I do next is I write a set of parentheses, and I'm going to leave myself enough space for 2 pieces that are going to go here. And the reason I'm putting 2 pieces, or spaces for 2 pieces, is because my original expression had 2 things in it, right? It was something plus something. If it had 3 things, like number 14, then I would have parentheses and then I have space for 3 things. But here, I just have 2. So what you do next is you have to go back and kind of reverse engineer this and think backwards. You know that you have to distribute a 6 through here, and you have to distribute a 6 through here. And what you want is your final answer to be what you started with. So to get this first one, 6y squared, what am I going to have to multiply 6 by to get 6y squared?
Y squared.
Y squared.
Y squared, okay. And that should do it, right? That should give me 6y squared. Then I have to move on to the second piece and ask myself, what do I have to multiply 6 by to get 6?
Plus 1.
I need a 1. And it's very important that you put the 1 here, and it's very important that you put a plus in between. That way you can actually get the distribution. And that's it. We have done the greatest common factor. I'm going to erase all this. This is our answer right here. And you can check your answer by just distributing. If you distribute, you should get back the original problem. So the method for GCF is to look at each term. First, look at the numbers, figure out what number goes in all of them, and then look at the letters. So let's move on to number 12. And I think what I'm going to do before I start is I'm going to write down in a little more detail what this actually is. Do y'all agree that the original problem can be written that way? Like we don't normally write y squared as y times y, but I could do that, right?
Yeah.
Okay, now there is a number here in front of the x. There's a 1 out front. Even though it's not there, it's there, right? So let's start with the number. What number goes into both 1 and 3? What's the biggest number that goes into both 1 and 3?
1.
Just 1, right? 1 is the only number that goes into both of those. So my GCF, my greatest common factor, is going to include a 1. Now you don't normally have to write that, but I'm going to. Okay, and then let's look at the x's. I have an x here. Do I have any x's on the second one?
No.
I do not. I have no x's. So you cannot have an x in your greatest common factor. It would have to be in both. So I don't have it. No x's are going to be there. So I move on to the next letter, which is y's. I have 2 y's there and I have 2 y's there. So what do they have in common? Do they have 1 y in common or 2 y's in common?
They're both squared.
We have 2 y's in common in each one, right? So I can write in my greatest common factor a y squared. Are there any other letters to look at? We've looked at x, we've looked at y, we've looked at the numbers. We're done, right? So parentheses, enough space for how many things?
2.
2, and now we just have to figure out what they are. So this is where I like to go back up and just look at the original problem. How am I going to turn, or what am I going to multiply? And I'm gonna get rid of the 1 here. We don't need the 1. What do I need to multiply y squared by to get xy squared? So you're really just asking yourself, what's missing?
The x.
Just the x. So I put x here. Okay, and then I have to look and figure out what do I multiply y squared by to get
3.
minus 3y squared. Minus 3, is that what I heard? 3? Yep, or you could say 3 and then make sure you put the minus between, or you could just put minus 3. And that's it. Box it up, you're done.
So you don't have to put the 1.
You do not, no. I was trying to illustrate that there is a 1 in common in both, and that's what comes out. Okay, number 13. So let's see if we can move through this a little bit faster. When you look at those 2 terms, what's the biggest number they both have in common?
3.
3, okay. How many x's do they have in common?
X1, just 1.
Just 1 x, right? This first one has actually x times x, but the second one only has a single x. So you can only pull out what's in common, and what's in common is a single x. So that means on the outside, I'm going to put a single x. Are there any other things I need to consider? I've considered the numbers, and I've considered the only letter I see there, which is x. So there's nothing else, right?
Nope.
Set of parentheses, enough space for 2 things. And then you just have to kind of play this game. What do you multiply 3x by to get 3x squared? So what am I missing?
X.
An x, okay. And then I can put a plus sign here because that's plus. What do I multiply 3x by to get 6x? What do I
2.
multiply by? Just 2, right? Just 2, not an x, just a 2. So if I distribute this through, I get 6x. That's it. Number 14 and 15 are a little more challenging. So let's try 14. Let's look at the numbers. 16, we have 3 terms this time. 16, negative 28, and positive 48. What's the biggest number that goes into all of those? So 2 goes into all of them, right? Because they're all even. But is that the biggest one?
4, right?
4, okay, so 4 goes into 16, 4 goes into 28, and 4 goes into 48, yes? Is that the biggest one?
Oh, 8, right? Oh, wait.
Okay, 8 goes into 16, 8
wait,
goes
no.
into 48, 8 doesn't go into 28 though.
Oh, yeah.
So 8's too big. I think there's nothing else, right? So it's looking like 4. I always give the advice of, you know, just try 4 first. Try the biggest one you can find. So put 4 here. And then we'll look at our answer at the end and see if we missed anything. Okay, how about X's? Do they all have something in common with when it comes to X's?
No.
Just one?
No, the first one has X squared. The second one has X, but look at the third one. It doesn't have any X's, right?
No.
To be a common factor, it must appear in all 3. So we have no X's to pull out. How about Y's?
You can pull out y2, y squared.
Squared, Y squared, and Y to the 5th. So 2 of them have 2 Y's being multiplied, but the last one has 5. You can only pull out what they have in common, which
Just
would
one
be
word.
Y2
Y squared.
in parentheses, right?
And in parentheses, enough space for 3 things this time. And now you have to just kind of play this game. What do you multiply 4y squared by to get back 16x squared y squared? So you have to turn the 4 into a 16. How do you do that?
4.
4. Okay, you have to turn the x, well, we didn't have an x squared. We have to make an x squared, right?
So 4x squared.
So we have to have the x squared, and we have to turn y squared into y squared, but it already is y squared. So 4x squared is the only thing that goes there. What about the second one? You have to turn 4 into negative 28.
So 4 times 6, 12, 18. I mean, 7.
Negative 7.
Yeah, negative 7.
You also need an x, right? Which you don't have an x. So you'll need an x. Do we need a y squared?
No.
Not here, right? Because we already have the y squared on the outside. And then the last one. So 4 times 12. So I put plus 12. And then I need a y to the 5th. I have y squared. How many y's am I missing?
Y cubed.
Y cubed. Y to the 3rd. There it is. So I was saying, you know, if you think that the GCF, that number, if you thought it was 4, but you weren't quite sure if there was a bigger number, my advice to you is to look at the end, look at the numbers that are still in here, and see if you can think of a number that goes into all those. 4, 7, and 12, and you're not going to find anything, right? 2 doesn't go in all of them, 3 doesn't, 4 doesn't, 5 doesn't, 6. So that's how you kind of know you've got the biggest number out.
Okay.
Okay. I think I'll leave that one to you. And that officially covers what will be on the test. All right. If you can handle that, everything back from the beginning last Monday, that first test, you should be good to go. Now we're going to move on to the next topic, which is going to be percents. But before I do that, I want to talk a little bit about, this is kind of, I want to call it random useless information, but I don't really want to make it like it's completely useless. So, but it's interesting math, and maybe if we take little detours every once in a while to talk about when math can get interesting, I don't know, make it a little bit easier in here for you all. So think about throughout history, the idea of wanting to send a message to another person. Okay, so like, I mean, we're talking go way back before phones, you know, if I wanted to send a message to somebody, but I wanted that message to be private, I didn't want anyone else to get that message, how could I deliver that message? So think about the struggle that humans have had over time in trying to communicate with one another privately. So does anyone know some of the ways that we did that in the past? You can go back as far as you want history-wise.
Like coding?
Okay.
Coding the messages?
Okay, like coding. All right, so one way you could code a message would be, say, take your alphabet. Right, and then for each letter, instead of using a letter, use a number. This would go on, of course, through the alphabet. So if I wrote this message down, wrote that down on a piece of paper and sent it off, what's my message?
Hi, Dad.
Hi, Dad, right? So let's say this is a super secret message and I want to send it to my dad, right? So I get some guy and I say, hey, take this over to this person over there that lives over that mountain. And then it's a very private message. Let's act like it's not, hi, Dad. Let's act like it's, you know, the troops are going to be coming in 3 days or something like that. Well, what happens if the person I send with that message gets intercepted and someone finds them and pulls that message? Do you think they're going to be able to break that code? Maybe, right? Maybe. Yes?
Yeah, maybe.
It's not that complicated of a code, is it?
Mm-mm.
But more importantly, doesn't my dad on the other end, or doesn't the person at the other end have to know what I did? Don't they have to know also that A is 1 and B is 2 and 3 is, like, don't they have to know that?
Yeah.
But what if I can't tell them that? How can I tell them that, right? I can't call them. So this is very problematic, because when you use something like this, not only does the person that's sending the code have to know how to scramble the letters, the person on the other end also needs to know how you scrambled them to begin with so they can unscramble them. Does that make sense?
Mm-hmm.
So at some point, those two people had to be in contact with one another, talked about it, agreed upon it, and then worked it out, right? Okay. So all of this goes into a branch of math called cryptography. All right. And the reason I'm sharing this with you is because all of you use apps on your phone and online banking and things like that. And you want to trust that your stuff is secure, right? So how do you know that your stuff is actually secure? What's actually happening when you go to your bank on your app on your phone? What's actually going on that makes you feel like nobody's going to break in and steal all your money, right? And take all your money out of your banking, deposit it into their account somehow, right? Electronically. Does this interest you all at all? I mean, I can stop at any point here. Should I continue? Your crickets. Yeah. So look, I mean, the reason I wanted to tell you this is because we rely on something very basic in mathematics to be able to encrypt our information. And when I tell you what it is, you're probably going to be a little blown away at how basic it is. All right. So you remember a second ago, I put the number 28 down and I told you do the prime factorization and we come up with 7 times 2 squared, right? Remember that?
Mm-hmm.
Okay.
Yeah.
I'm gonna do a slightly different number because it'll be a better example. If I start with 2 prime numbers, so I'm gonna pick 2 prime numbers, 3 and 7. If I take those 2 together and multiply them, I get 21. So 21 is composite, right? And 3 and 7 are prime. So these are my 2 prime numbers, prime, and this is prime. And this is composite. Okay, so let's see if I can make this make sense to you all. If I told everyone right now, hey, the number is 21, could you break it down into its prime factorization? Yeah, right, 7 times 3. It might take you a few seconds, but you could get it, right? All right, so the way that encryption works is this. You have this person here right, who wants to talk to this person here. All right, they want to talk to one another. So let me put an arrow. What we're trying to do is send a message this way, okay? This person on the left is trying to talk to the person on the right. The person on the right, what this person does is, let me open their mouth and put some eyes on them. They're yelling out the number 21. Everybody can hear that number, okay? And that's what's known as the public key. Okay, so the person on the left, I'll make him my red person, okay, is trying to send a message to the blue person, right? What the red person does is they get their message, okay, and then they use this number 21 to scramble the message. So there's a way that you can use that number 21 to scramble it. So this is the real message, and this is the coded message. So like earlier, the real message was "Hi, Dad." The coded message was whatever, 89414, something like that. So the person on the left, the red person, they're using the number 21 to scramble. Okay, y'all okay with that? Then what they do is they yell back to the other person. They yell the scrambled coded message. Anybody in the world can intercept that. Okay, anyone can take this coded message and look at it. But here's the key. The only way they can break that code is to know that the number 21 came from 7 times 3. Them knowing that the number is 21 will not allow them to break the code. They have to know that 21 came from 7 times 3. Okay? Which we all know, right? So let me redo this a little bit. In the real world, here's how it works. The public key, what this person on the right has to do is they have to come up with 2 prime numbers. I used 7 and 3 before, right? But they don't use 7 and 3. It's usually a 40-digit number, 40 digits. And this one is 40 digits. And when you multiply 2 40-digit numbers together, you get an 80-digit number. So they yell out over here, right? Their key is an 80-digit number. Everyone can hear that. This person takes the 80-digit number, creates a code, and yells it back. The only way to break that code is if you know the 2 prime numbers it came from. So you have to figure out what those 2 40-digit numbers are. You know what's wrong with that? Is that it can't be done. It's so hard to do that if you have every computer on the planet trying to break that code, it's going to take 10 times the age of the universe for it to happen, which means it's not going to happen. But computers are getting faster and faster, right? So maybe one day we can. Well, that's easy. How could I make this code even stronger? Instead of using 40-digit numbers, I could use 50-digit numbers, 100-digit numbers. And as I add more digits to my primes, it becomes harder and harder for computers to do it. So what is my point? My point is that if you or any other person in the world can come up with a way to take a composite number of any length and easily break it down into its prime numbers, if someone could come up with an algorithm to do that, the world as we know it would change. It would be complete chaos. Everything, nothing could be encrypted anymore. Nothing. And so we would lose all of our security. That makes sense?
Yep.
But it just comes down to a very simple math problem. Can you take a number and break it down to the primes it came from? someone can overcome that hurdle, well, we'll all be, I don't know. We'll see. I don't know if we'll get there. I don't think we will. I don't think we'll ever be able to come up with an algorithm. So math in the real world keeps everything going, I guess. All right, y'all ready to talk about percents? All right, so percents. We all hear percents all the time. You know, let's see, there's 20 people in here. Wonder how many of y'all have Androids? Android phones. Does anybody have an Android phone? One.
Yep.
1, 2, okay, 2, me, 3. So let's just go with 3. I've had classes where nobody has an Android except me. So I think, let's say out of 23 of 20 people have Android in here. Android phones. I think I just heard thunder. That's weird. Maybe not. Okay, never mind. That was a trash truck. So 3 out of 20 people have Android phones. If I turn that into a fraction, 3 out of 20, and I get on my calculator, right? And I do 3 divided by 20. Whoa, 3 divided by 20. I get 0.15.
Was that 15%?
Okay. Which is 15%. So where did that come from? Well, whenever we see a decimal, any number that's a decimal, if we move the decimal point 2 places to the right, okay, then that would just become the number 15. Then we would put this percent symbol. That's how we convert decimals over to percentages. Now, I'm assuming that some of y'all have seen that. Someone responded, so I know at least one person has. So what we're saying is that 15% of the people in this class right now have Android phones, right? So percent is a way of measuring how many things you have out of a certain number. So when we write 15%, we actually mean 15, because does that mean that 15 people in this class have Androids?
No.
No, only 3 did, right? So what does 15 mean? It means that 15 out of 100 students have Androids. Now, we don't have 100 students in here. It's saying that if we did have 100 students in this class, at that same ratio proportion, 15 of them would have Androids. And it's just because it's easy for us to think about 100. Like, it's just an easy way for us to process it. Another way we could have posed this is that we have 17 of 20, I guess, have Apple, right? Apple or iPhones. And so that would be 17 out of 20, which would be 0.85. And converted over to a percentage, that would be 85%. So that means 85 out of 100 students have iPhones. Again, it doesn't mean that we have 100 students. It just means that if we did have 100 students, 85 of them would have your iPhones. So we just need to make sure we understand what a percentage is. It's telling you how many out of 100 you have, if you had 100. All right. So let's look at these problems. These problems always seem to cause students trouble because they try and solve them without writing anything down. So my goal right now is to help you look at these problems and find a way to turn each of these statements into a mathematical equation. You know, we just got finished talking about equations of linear equations of one variable. Every single one of these problems that we're about to look at, we are going to try and turn into a linear equation with one variable. We're not just going to get on our calculator and start popping away. We're going to try and convert it into math first. So to convert it to math, we have to understand what certain words mean in the real world. So the first key word in a mathematical expression is the word is. What do y'all think the word is represents in a mathematical statement?
Equals, right?
Equals, yeah, equals. So whenever we see the word is, we can just translate that directly into equals. And then over here next to it, I have 21, which is just a number, so I have 21. Do you see that I haven't even read the problem, and I already know that it's going to say at the end equals 21. All right? Another thing we have in here is the number 200, right? So I could put that down, but let's just look at what's in front of it. What percent of 200? So what percent? What percent is the thing they want to know, right? They want to know what percent of something. So what should I call the thing we're looking for?
X.
X, right? It's unknown. It's the variable. It's the thing we don't know. So let's call the what percent, and I'm going to take that up. I've really got to get used to that. What percent? I'm going to call it X. Okay, next keyword, of. You all know what the word of means in math. Convert it over.
Divide.
Nope. Close.
Oh, divide.
It's I don't know. I don't know if I heard what people said, but this is multiplication.
Oh, wow.
It's multiplication.
Oh, okay.
And then the 200 I can put next to it like this. So when someone is asking, what percent of 200 is 21? We're really saying X times 200 equals 21. That's the mathematical linear equation. Do y'all see the linear equation? I'm going to write it a different way. 200x equals 21. That's just because when I multiply x times 200, it's the same as multiplying 200 times x. It doesn't matter what order I put those in. So this is a linear equation. Are both the left and right hand sides simplified?
No. Yes, no.
Well, there's nothing I can combine together, right? On the left side by itself and the right side. So it's already simplified. Do I need to isolate the variable x, or is the x term already by itself?
Very right.
You need to, excuse me, you have to isolate it.
It's by itself, but the next step would be to make sure the coefficient is a 1. And right now the coefficient is 200, isn't it? That's 200 times x. So how do I get rid of the 200?
Minus the 200?
Careful.
Divide.
Because it's been multiplied.
Divide. Oh, divide.
Divided by 200. There you go. Okay, so on the left, the 200s are going to cancel. I'll just have x. And then over here, I have 21 over 200. Now, I'm going to get on my calculator, and I'm going to do 21 divided by 200. This is the first time I'm actually going to my calculator to get a decimal. I get 0.105. That's what x is.
So
Do you think we're done?
No, we got to move the decimal.
We got to move the decimal. And the reason we have to move decimal is because in this problem, it said what percent. Right now, we have a decimal answer, but to get a percentage, we have to move the decimal 2 places to the right. 1, 2, so we have to put it right there. So it's actually going to become 10.5%. Now I know there's always going to be a student who's going to sit there and say, hey, look, I got 10.5% and I didn't do any of that. Can I do that on the test? And I would say, sure, proceed with caution, because if you give me the wrong answer and you just did it all on your calculator without any work, you're just going to get it wrong. Whereas if you at least try to set up the equation, again, this goes back to the whole partial credit thing. So you want to show as much work as possible. Now, I recommend that when you're done, that you go back and you try and just like plug in your answer and see if it makes any sense. So I'm going to come up here, I'm going to scratch out what percent, and then I'm going to put 10.5%. And I'm just going to read it to myself and see if it makes sense. 10.5% of 200 is 21. Do you know what 10% of 20 would be?
10.
That's 10% of 100.
I mean,
2?
20. It would be 20. 10% would be 10% of 200 would be 20.
Oh, I thought you
The
were
10.5% of 200 should be 21. It makes sense. Okay. Now this isn't always going to work, but you just want to make sure that if you try and check it, it doesn't give you something that doesn't make any sense at all. Let's try number 2. 15% of a number is 19.5. So somebody tell me what they want me to write down first. I mean, I'll do anything, but I'm trying to get an equation set up here.
15 times.
15 times. So you're using the of as times.
Yeah, and then the number would be x.
Number, you don't know what that is. Let's make it x. Okay.
Equals 19.5.
Is equals, and then 19.5. That's almost perfect. There's one mistake. You said to write down the number 15. Where did you get 15 from?
15%.
15%. Yeah, I understand exactly what you're doing. However, remember when we did 3 out of 20, right? Or 3 out of 20 androids, and we said that that was like 0.15, right? Didn't we say it was, yeah, it was 0.15, and didn't we then convert that to a percentage, 15%? So what is 15% written as an actual number? It's not 15, it's 0.15. So when we come here and we convert, we actually have to convert this percentage to an actual number if we're going to put it into the equation. So I actually want this to be 0.15. Does that make sense?
Yeah.
Okay. So we have our linear equation here. It looks like this. It's 0.15x equals 19.5. That's a linear equation. We have one variable in there. It's simplified on each side. The x is isolated. There's only really one thing for me to do, and what is that?
Divide by 0.15.
Divide by 0.15. So you have to be real careful when you go to your calculator here. You're going to be doing 19.5 and divided by 0.15. I'm getting 130.
Yeah, 130.
Yeah. Now, before I box that, I should have checked to see if I have to do anything with that. Remember, x was a number, right? X was a number, and 130 is a number. So we don't have to do any converting. We're not going to change it to a percent or anything, because it's saying of a number, and we determine that that number is 130. So if we write this out again, 130, and we read it, saying 15% of 130 is 19.5.
Sounds right.
Okay. Yeah. So for some people, they're you know, I like to just throw other percentages in there. So like, what would 50%? 50% of 130 would be like half of it, right?
Mm-hmm.
Okay. So 15% should be less than that. So this is looking good. I think we're good. Okay. What about this next one? What could I write down here?
25 equals.
25 equals.
40% of what? So point.
Yep. Point 0. That's 40% converted to a decimal. of is
times x.
times, and then what is what you're looking for, right? X.
X.
So we've got 25 equals 0.40x. And just like the ones before, all we have to do to get x by itself is divide through by the coefficient. So divide through on both sides by 0.4. $62.5.
But it's asking for percent, right?
It is not. It's saying 25 is 40% of what? The only time you're going to ever convert it back into a percent is if it says what percent.
Oh,
Then you'll have to convert. How would this last one set up?
okay. What is 35% of 200?
So what would be
So it's going to be equals 35, right?
equals 0.35
Oh yeah. Equals 0.3.
of is times and then 200. Do you see how I'm translating that? 35% is 0.35 of is times 200 is 200 is equals, and then what about the left side? What?
X.
X. So here x is already solved for. What you need to do is just do that multiplication on your calculator. Do 0.35 times 200 and you'll get 70.
X equals 70.
So 75, or sorry, 70 is 35% of 200 is what we're getting. Okay, I think I will leave the next two for you. Let's get to some word problems. Did y'all like how we did the breakout groups last time? Would y'all like to do that for these word problems? Did y'all find that useful, or would you prefer that I just work through some of these?
I mean, we can do the breakout rooms. Either way works.
Why don't I do one of them? Of course, they're all going to be different, but why don't I do one and then y'all can try? There's only 3 problems here. You know what? There's only 3. How about I do this? Let me read it first. Yeah. Yeah, so why don't I let you all, I'm going to put you in breakout rooms. Hopefully people are actually here. There's a lot of people that are muted, but I don't know if they're actually physically there. So why don't we do breakout rooms? I'll put, I think I'll put 4 people in each group, and let's just make sure you can work through each of these 3. And I'll give us, I don't know, 15, 20 minutes, see how far we get, or see how far you get, and y'all can just ask me for help if you need, like we did last time. All right, let me get this. Breakout rooms, and you're just going to be kind of randomly assigned. And you're either going to have 3 or 4 people in the room. Okay, here you go. So you've been invited to join a room. Go ahead and go in there and work together and see if you can get the 3 answers. I'm bringing everyone back. We'll get going here once everyone joins back in.
Okay.
Okay, so I think everyone's back. Okay, so look, there's going to be more than one way to solve these problems. Everyone's going to kind of have maybe a different approach. Let's just run through these real quick. The first question, number 7, I like to try and do it kind of visually. We have a total number of 15,435 students that are at Northwest Vista College. 30% of them are going to go to UTSA. So we need to figure out what 30% of that number is. So it's is like multiplication here, even though it's not written in the word problem. We're trying to find what 30% of the people at Northwest Vista were. And in that case, it's 0.3 times 15,435. And that gives us this number 4,630.5. That's about the number of students that are going to transfer to UTSA. Then of those, 12% of those people are going to be biology majors. So we need to figure out what 12% of the 4630.5 is, and that's what I did on this last operation. And we get about 555.6. Don't worry about rounding. We're talking about people, so you can't really have like a decimal of a person. So we're just going to say roughly 555 people are going to be going to UTSA and majoring in biology. Now on number 8, the big difference is they don't give you how many students were at Northwest Vista. Like in the first problem, they give you 15,435, but in the second one, they don't tell you how many. But they want to know what percent. So one tricky way you can get this is to just act like there's 100 people at Northwest Vista. And then at the end, your answer is going to be a percentage because it'll be out of 100. So I started, it's basically all the math that I did above, but using 100 for my starting population for Northwest Vista. So I started 100, I take 30% of that, I get 30. I take 12% of that, I get 3.6. So 3.6 out of 100 students are going to go to UTSA and major in biology. So that's the percentage. Go ahead, Lorenzo.
So the 3.6, we didn't have to make that into percentage. It was already a percentage.
Yes, because it's out of 100.
Oh, okay. That's already messed up.
So if you, now I understand what you're saying, because if you take 3.6 and you convert it to a percentage, you're going to get 360%. But that answer shouldn't make sense because you can't, 300% is more than 100%, right? So you can't have more people at UTSA taking biology than you had to start with, right?
Yeah.
Okay. And then the last problem, I didn't do the work on it. The last one's actually, I think, easier than the first two, because it just says there's a poll that they take out of 976 people, 68 say they drink alcohol every day. So what percent say they drink alcohol every day? All you have to do is take the number of people who drink every day and divide it by the people in the poll, and you get a decimal for that. And then you convert that decimal to a percentage, or to a percentage. So 68. This is kind of like the iPhone problem that we just started with.
Oh, you do 68 divided by net by
Yes.
the 976?
Not the other way around.
Oh, okay.
So it's kind of like how many people had Androids out of how many people we had in the class, right? So it's always going to be the part out of the total. Always, that's the way you want to set up your fractions. What part of what part are we talking about out of the total? So if only 68 out of the whole 976 drink, that's the way we get that percentage. I'm getting as a decimal point 0.06967, something like that, which
Yeah.
we could move the decimal point over to convert it to a percent. This is about 6.967%. You could give me 7% there, that'd be fine. You'll get more practice with this on your homework. And keep in mind, this is not on the test on Wednesday, so you don't have to like stress out too much about it right now. But you do want to make sure you keep up with the homework on it. Okay, so proportions are related to percentages. This is the last thing we're going to do. We only have about 10 more minutes, but there's only 3 problems. We're not going to do applications of percents today. We're just going to try and knock out these 3 problems. So a proportion is different in turn, well, relative to a percent. Proportions are different because it's not out of 100. It's out of however many they give you. So let me read through this first one. One bagel has 320 calories. How many calories are in 2.5 bagels? So this first sentence, one bagel is 230 calories. That is the sentence that you will use to set up what's called your proportion. And watch the way I write this. It's going to be a fraction. You put one bagel over 320 calories. There we go. That is what we call a proportion. One bagel, there's one bagel to 320 calories. Now, anytime you have proportions, you can always flip them over and write them the other way around. Very important that you hear what I just said. Anytime you have a proportion, you can always flip it around and it's equivalent. So the first one is saying one bagel, for every one bagel, you get 300 calories. The other one is saying you get 320 calories per bagel. It's the same thing. So you can write it either way. Now, why is that important? Well, it's important because the way we solve these problems is as follows. What we're going to do is we're going to look at the question now. How many calories are in 2.5 bagels? So what is it that we want to know? Do we want to know how many calories there are, or do we want to know how many bagels there are?
How many calories?
Calories. Okay, so I'm going to sit right here, and we want to know how many, right? So I'm going to put X calories over 2.5 bagels. So what I'm doing is I'm setting up a proportion using the second sentence there, but I'm putting X for calories because I don't know what X is. That's what I would like to know. Does that make sense to everyone?
Yeah.
Yes? Now, what I'm going to do is next to it, I'm going to write equals. And then what I'm going to do is I'm going to pick one of those 2 proportions to work with. So which one do you think I'm going to pick and why? The one on the left or right?
The right.
One. Because it's already set up with the calories on top.
Yeah, you want to pick the proportion that has the same format, calories over bagels. So I'm going to write down over here 320 calories over 1 bagel. And then what you're going to do is what we call cross multiply. You're going to multiply it across like this and across like this, and you're going to bring your equal sign down. So you're multiplying X times 1. What's X times 1?
X.
X.
X, okay. And then you're going to do the second multiplication, which is this one right here, the one in blue. What's 2.5 times 320? So you get your calculator out, maybe.
800.
800. 800 what?
Calories.
Calories, because we wanted to know what calories, right?
Yep.
So if one bagel has 320 calories, that means 2.5 bagels, 2.5 bagels will have 800 calories. Does that answer make sense?
Yes.
Yeah, right.
Yes.
If it said like 80,000 calories, we'd be scratching our heads. All right, let's do the second one and see if we can start to pick up on the kind of the method. A leaking pipe can lose 27 or 24.7 gallons of water in a week. Okay, I can set up a proportion. I can write 24.7. I'm just going to put G for gallons in 1 week. Or I could write 1 week over 24.7 gallons, right? So that's, to start everything out, those are the two proportions I have to choose from. Now, look at the question. How many gallons are lost in 30 days? So I'm going to put X, and then X what? What am I looking for?
Gallons.
Gallons. So X, G for gallons over. Does anyone see the issue here?
Yeah, they're both gallons.
What am I supposed to put X gallons over?
Oh, 30 days.
30 days. Do you see the problem? What's wrong with this?
10 days.
Oh, it's in days.
Days, right? Wasn't our original proportion in weeks?
Yep.
So I have a choice right now. I can either convert 30 days over to weeks, or I can take the original proportion and change my weeks to days. What's easier? Is it easier to turn 30 days into weeks, or a week or a single week into days?
A single week into days.
Yeah, so why don't we go back to the left and let's scratch out week and let's just put 7 days, because that's the same as a week. And here we'll scratch out a week and put 7 days. And now everything has days and gallons. So you want to be careful with that. Now I need to set this equal to,
It's going to be 24.7 over 7 days.
it's going to be 24.7
gallons over.
gallons over 7 days. And now we cross multiply. So multiply here to here and just do the numbers, the number and the letter. So 7x equals, and then multiply across like that. What do you get? So you'll need your calculator for that.
741. Or no?
741. And do you all recognize this as a linear equation? You can solve this for x, can't you?
Oh yeah,
What do
we
you
can
have to do?
divide by x.
Divide by 7. Divide by 7. You're going to get a decimal, I'm sure.
105.
105 point, let's just say 9, we'll round it. Okay, 105.9 what? What was it that we were looking for?
Gallons.
How many gallons, right? How many gallons? So in our answer, we need to put gallons.
So 105.9 gallons are lost in 30 days.
For this particular leak.
Yeah.
Did I mention to y'all that I had a leak in our house? Did I mention that at the beginning? So we had our entire first floor flood, and our water only ran for about 6 hours. The leak only ran for about 6 hours. And my estimate, and I'm pretty good with estimates, my estimate is that we lost about 2,000 gallons in 6 hours.
Damn.
And I think we had about 2,000 gallons on the floor in the house. So this leak they're talking about is a very, very slow leak compared to the one we had. Okay, next one. Now look, I'm going to say this again. I'm sure that some people are able to solve these problems without doing all of the work that I'm doing. However, trust me, later on as we get into what's called dimensional analysis later, it becomes very difficult to do all this in your head, so you need a systematic approach for it. So that's what I'm trying to establish here is a systematic approach. On the left side, what we're doing is we're setting up our proportions. And on the right side, we try and set up what we're looking for. And then we use that to determine which proportion we're going to use. That's kind of like the template of what we're doing here. So for this first part of this problem here, last one here, Joe's heart beats 11 times in 10 seconds. So I'm going to put here, I have two different things I can write. I can go, we're talking about his heartbeat, right? So 11 beats every 10 seconds. Or I could write every 10 seconds, there's 11 beats. Okay. At that rate, how many times does his heart beat in 60 seconds? So what is it that we're looking for? How many times does his heart beat, right? So we're going to have X beats
And then over
60 seconds. And now that should tell me which one I want to use. So I want to use the 11 beats over 10 seconds, don't I?
Yep.
So 11 beats over 10 seconds. And then we do our cross multiply. So I'm getting 10x equals 66. And then I'd have to divide by 10 on both sides. So I get x equals 6.6. That doesn't seem right.
It's
No,
660.
it's 60 times 11.
Yeah, 6 times 11. It's 660.
That's 160. Yeah.
I don't know why I put 66. I apologize. Okay, so there we go. I was like, if your heart's beating 6 times in 60 seconds, then you need to be at the hospital. All right, so now divide by 10 and you should get 66 beats, right?
Yeah.
Heartbeat. So Father's Day is coming up. So my wife just got me a Fitbit. So I guess I'm going to be able to track my sleep and stuff. So I know what my resting heart rate is. What's a good resting heart rate?
Which
What's
one
that?
did she get you? Which one did she?
The Versa 2. She has the
Yeah,
Ionic.
that's
She has the Ionic.
that's what I have.
Okay.
I've got the Versa too. I got it like 6 months or yeah, like 4 or 5 months ago. I love it.
Yeah. I had the Samsung one, but I had to charge it every night. And to me, that's not a watch, you know? The watch is something.
This thing I maybe once a week.
Yeah. All right, everyone. So we're at the end here. So what's going to happen now? You're going to go and study and review. The test is going to be on Wednesday. We'll come in here, make sure your camera's working and all that. And then we'll take the test. We'll be done. And when we're done with the test, you'll have to send it to me. So there will probably be a time in the middle of the class where if you're done and you've already submitted it, you're probably going to get a 10, 15-minute break to just chill out. And then we'll have an official time we start class up. And when we do, we'll pick up with applications of percents. We'll do that and then move on. I think after application of percents, we move into the next section, scientific notation. Yeah, okay. So
How many questions are on the test?
I'm sorry?
How many questions are on the test?
I don't know. I'm gonna try and determine the length of the test based upon how long it takes me to take it. So my goal is to make a test that I can finish. Let's see, I'm gonna give you all probably what, at least 75 to 80 minutes. So it should take me no longer than like 15 minutes to take it and finish it. So that's the way I'll usually do it. It's like however long it takes me, multiply that by like 5 or 6, and that's how long I give you, if that makes sense. So I don't know how many questions, I haven't written the test. Yeah. I don't even know, I don't think on this computer that I have any copies of old tests, but they'll be very similar. Like I said, they'll be very similar to the homework. Okay. Any other questions? Any homework questions? I know we're out of time, so you can bail when you want to bail, but does anyone have any questions on homework or anything?
Yeah, I wanted to talk, maybe do a couple more of the poly, let's see here.
Polynomials.
Yeah, the polynomials.
You mean out of the homework or
Yeah,
just?
out of the homework, or
But,
yeah.
but you're talking about ones that I have not assigned that go with what we did today. Or is that what you're talking about?
No, I'm just like just polynomials as a whole thing, like the process of again, how to the order to do it.
So look at my screen. Is that what you're talking about? Do you want to look at the homework for polynomials?
Yes, yes.
Okay, so that's homework that you have not started, right? So maybe we can start to look at, you know,
No,
any of
I'm talking about from the other day, like the other day homework.
Okay. Well, those are equations. Those are your linear equations. And this was your.
Oh yeah, we didn't do that. Oh, okay, yeah. Never mind. Okay, never mind. Never mind. I'm good.
Sure. Yeah. I mean, the homework for polynomials, you haven't really had an opportunity to do yet, right?
Yeah. I'm lost.
But if there's anything here that you look at that you want to go through one, I'm happy to go through one.
No, I'm good.
Okay. Anybody else?
I have a question.
Mhm.
On the test day, do we have to have a blank paper or something, or do we have to print out the actual question from the canvas?
Oh, good question. No, you don't have to print anything. I'm going to send you the test, so you're going to need to be able to see it on your computer. But
Okay.
you don't have to print it. You're going to do all your work on your own paper.
Okay, I see.
And then that's what you'll take pictures of and send to me.
Okay, got it.
Yeah,
Thank you.
good question. Anybody else? Okay. Well, I guess if there's nothing else, Lorenzo, do you have something or?
No, I'm good.
Okay. I guess I'll end the meeting, and then if something comes up between now and the test, just send me an email or text me. If you want a more prompt response, text me. Just remember, if you're going to ask me a question about a particular problem, send me a picture of the problem, send me a picture of any work you've done on it, and I'll be able to help you out. Just make sure you include pictures of the problem, because if you just say number 12 out of the homework, then I have to go look it up, and if I'm out doing something, it's hard for me to help you. So yeah. Okay. All right. I'm going to end this here. Y'all have a good rest of your day.
All right, thanks.
Okay. Take care.
Bye.